So let's do an example. Let's say that we've got two metal plates, and let's say they're separated by a distance of 1.25 centimeters. One of them is positive, one of them is negative. So that means there's an electric field between the two. Well, I'm not going to give you the electric field. Instead, I'm going to give the voltage between the two. So let's say the difference in voltage between the two is going to be equal to, let's say the voltage is equal to 275 volts. Now the question, which is the higher voltage, which is the lower voltage? Well, this is the high voltage. That's got to be the low voltage because the electric field goes from high to low. So if I have an electron right here next to that negative plate, so we have some kind of minus Q here, plus Q there. This negative plate, and I heat up the electron, I heat up the plate, or I hit it with a bit of radiation or something. The electron comes loose. It's going to experience a force going across this way. So I want to know, question, how fast is it moving when it hits the other side? Yeah, I know, this is complicated. We got V for velocity, we have got V for voltage. So we just need to pay attention to context. Okay, so I want to know how fast is it moving when it hits the other side. So we think about this and we say, okay, it's a distance here, there's the voltage. Okay, so I want to know how fast is it moving. So that's V naught plus acceleration times time. We'll assume it starts from rest. So we need to know the acceleration and time. So we know that x is x naught plus v naught t plus 1/2 at squared. Okay, so x is 1/2 at squared. So that means we could solve for t. T is going to be square root 2x over a. Plug that in up here. So that's a times square root 2x over a. And so the velocity is going to be square root 2xa. Well, that should look familiar. That's all physics 1 stuff right there. Okay, so this is velocity, so that means we know x. X was given. X was 1.25 centimeters. I just need to find a. Well, how do I find a? Well, a is F over m. Okay, so that means I need to find the F. Well, the F is going to be Q times E. How do I get that? Well, I know that V is going to be E times D. Well, I'm actually going the opposite direction. I'm going to take absolute magnitude here. And so that means that E is going to be V over D. So that's going to be equal to 275 volts divided by 0.0125 meters. So the electric field is 2200 volt per meter. So that means that this is going to be 1.602 times 10 to the minus 19 coulombs times 2200 volt per meter. And so that gives me the force, and the force turns out to be 3.52 times 10 to the minus 15 newtons. Well, if I know the force, 3.52 times 10 to the minus 15 newtons divided by 9.11 times 10 to the minus 31 kilograms. That gives me the acceleration, which is 3.87 times 10 to the 15th meter per second squared. Okay, well, I already know that the velocity is square root 2x times a, so that's going to be the square root of 2 times 0.0125 meters times the 3.87 times 10 to the 15 meter per second squared. Okay, and so that means the velocity when it hits that other plate is going to be 9.83 times 10 to the 6 meters per second. Okay, so fantastic. Well, you know what? That's long and hard. I don't like doing long and hard. So let me show you a shortcut to get the same answer. So we got this. One's plus, one's minus. Okay, 1.25 meters. And I told you there's 275 volts between the two. So the electron starts here, goes there. So the change in energy, the change in electrical energy is going to be basically, minus EV. Okay. Well, where did the energy go? It dropped by EV. Where did it go? Well, it became kinetic energy. Kinetic energy is 1/2 mv squared. So we have EV equals 1/2 mv squared. Okay, so V is going to be the square root of 2EV over m. So that means this is going to be the square root of 2 times 1.602 times 10 to the minus 19 coulombs times 275 volts divided by 9.11 times 10 to the minus 31 kilograms. And so that gives me a velocity of 9.83 times 10 to the 6 meters per second, which is exactly the same number that I got doing the problem the long way. So this is another way of getting that same answer using this same problem. This way of doing it is I think a little bit easier, but either way works. Either way uses the concept of voltage and energy. And so that's what's important here.